Thanks thanks very much. Right, so everyone, can you hear me? Thumbs up, yes? Good. First, I'm going to give you a quick introduction to ourselves at Center for Net Zero that you can see behind us. And we're an impact-driven research unit in London. And what does that mean? It means that we're driven by the results and impacts that we make on energy systems around the world, on policy making that is done by cities and national governments, and impact on the use of cleaner and more sustainable energy all over the world. And we exist because we want to build that future energy landscape, and because we're part of a very tech-driven company within Octopus Energy, it makes sense, of course, that we work at the intersection of tech, energy, and climate. And what we do, I mean, of course, our purpose is, because we're a research unit tackling the most interesting questions in the energy sector, and we have our own independent group of analysts and data scientists and communicators who collaborate with academics and partners around the world. And we really want to work with them on co-designing that future energy system and being as open and transparent more open and transparent than others around the world, because we're independent and non-commercial. So what does this mean for for what we offer to others? Well, we have really deep expertise in data engineering, artificial intelligence, and technology, combined with that deep knowledge of the energy sector. So those of us who have worked across the space in data, energy, and climate change are really kind of the core of our team. And part of what we really fuels is that access to data across the domestic and non-domestic sectors. And Octopus Energy operates in 14 countries around the world as a retailer in 10 of them, including five in Europe and Japan, Australia, and America. And we also have been developing technology platforms that really organize the data exchange between consumer and industry and the technology grid and the electricity grid. And one of the things that was most kind of interesting things to me as an American is that the investment company founded by Al Gore to promote climate change is now one of our investors. And so yeah, that was an odd moment for myself to sell some of my shares in Octopus Energy to Al Gore. That was a wild moment. Anyway, so welcome to our project on clean energy cities. And so I'm the manager of it, and Danny Lopez is our research analyst, and it's supported by C40 Cities. And I know that one of the team over there has spoken to you and given lectures to you, and the World Resources Institute, who I've introduced before. So what are we going to do today? Well, it's about cities, energy, and kind of the use of AI and machine learning and the potential for it in the future. So first, we'll talk about the typologies of different cities that we find around the world for their energy use, kind of almost like their energy behavior as a city. What does this mean for flexibility? We're moving from a system where flexibility is centralized to one where it's decentralized and put in the hands of consumers and businesses. And then finally, in automation, how do we actually enable people that have control of premises all over in a decentralized energy system, which is decarbonized, to be able to use digital technologies effectively and in a fair and fast way. One thing that we do know is that there's awareness at all levels of international and national governments that cities really are at the center of fighting climate change. And the IEA say that the International Energy Agency, I'm going to try to not use so many acronyms that people may or may not know, say that in 5 years, 95% of electricity generation will be renewable energy. Half of that will be solar. Of the generation being put online. So obviously that's adding to what's existing right now. And what we do know as well is that as energy systems decarbonize, we move from the heating and buildings with our own boilers that are on site, delivered with gas, that the engines that we drive and in transport will go from petrol and gas to electricity. That it will become much more decentralized in the future. You're not going to be building these massive pieces of infrastructure to deliver ever more electricity into cities and import electricity into cities. It's not financially sustainable. People will oppose the building of more and more electricity kind of pylons into cities. And that really is a driver of cost as well. That's the World Resources Institute. They say that infrastructure spending, if it's done in the same way as beforehand, will triple for countries around the world to something on the order of 8 trillion a year if people don't change course from what they do right now, which is simply engineer a system to deliver ever more electricity into cities, to supply electricity as the fuel for heating, cooling, and transport as we move away from fossil fuels. And they'll be leaning on city leaders to solve their electricity congestion problem that we're often hearing from from many people around the world. And well, one of the reasons that we established this program in Clean Energy Cities is that cities are best placed to try to organize this problem. And they know that you can't really build your way out of those problems from the experience they've had, for example, with traffic congestion in the past. What is happening right now? Well, we're going from where we were 10 years ago with a very linear system in electricity, going from generators through to homes and businesses. And maybe there's a little bit of storage intermediating in between, but it's just trying to solve very short-term and very small-scale problems in frequency and capacity. Now we're in a position where there's more local generation from solar and wind that is happening closer to cities, but there's not much of it right now. And that is being really organized in a centralized fashion. Export tariffs, for instance, that are being delivered towards individual households. It's not really seen as part of a local energy system. It's just added into the centralized system as before. And what we have in the future is almost an infinite number of microgrids that make up cities, that the local generation and storage never really participates in what we call in electricity the capacity market. It really is part of what is being generated and consumed locally. And one of the things that you'll see later in the lecture is that how do we get towards almost a constant imports of electricity hour by hour over the day, which makes the most stable and cheapest grid that you can have in the future. Because if you don't do this, you're probably talking about adding $100, $150, even $200 a year onto everyone's energy bills to pay for electricity infrastructure, which acts in a linear way that you had before. So it's in everyone's interest for many different reasons to do so. And I will skip through this because I just explained all these 3 slides. And many people will be wondering, what the hell are we going to do? How are we going to organize this? How am I expected to really participate in an electricity system where I have local generation in my area, I have local storage in my car, I have local storage in my building, how does this actually how is it actually going to play out? And this idea of flexibility in the future is really going to become local. We're going from a system now where you have what we call dispatchable energy, which is organized at in a very centralized way. Um, uh, right now at about 50 or 57 gigawatts of capacity that you have right now. And just to give you an idea for scale, a whole country, in this case, Great Britain as a country, the total amounts of electricity being put into this, being consumed, the power consumption is about 148 gigawatts. That's out there. So to give you an idea of scale that we have. And in the future, the amount of local flexibility, ones that are actually being asked of to have PV panels available, to have electric vehicle batteries that are able to both charge themselves and provide electricity into the system, for home batteries to do the same, for people to change their electricity consumption from 6 p.m. in the evening at the very peak when everyone's wanting electricity to 1 p.m. and 1 p.m., 2 p.m. in the afternoon, when there's less strain on the system, for instance. That's something which is quadruple what it is now. So it's the way that people experience energy is going to be so much different. And why cities are part of this leadership, as the local generation, local storage, and inside cities start to increase, the governance starts to shift from something which is controlled nationally or in partnership with grids to local authorities. And you need a lot of buy-in from mayors from residents and businesses, and there's a lot of levers at their disposal which they're still learning about right now, because energy has typically not really been on the menu of city leaders' policies and strategies over the past several years, from procurement for public buildings to the digital skills that are being needed to use automation, to training of installation staff for all these different heat pumps, electric vehicles, other transformations that need to happen. So we've taken a number of cities around the world, 17 cities around the world, and taken data from them across trying to think about their demographics, what their current decarbonization plans are in the country. And we started to also introduce some ideas of what we call urban flexibility and consumer flexibility, to measure what is the contribution of the pattern of land use to future energy, the future energy system. What is the amount of local generation and storage that actually can start to meet that demands based on the land availability, how much irradiance and wind speed that there is around that city as well. And also try to think about, of course, consumer flexibility, to be able to understand what are the things that actually incentivize people to shift their electricity from peak demands and non-peak areas, or even reduce it. And of course, what is the role of innovation? How many different ideas that are appeal to that local market are happening as well? What is the wholesale and retail market look like in providing, for example, real-time pricing, which really reflects the carbon intensity of that hour? And because right now, most of the time, the way that we experience pricing is it's just the same price all day, and that will change quite radically in the future. So we developed a number of profiles of cities. So these are just some examples of work that we've done before, and what you see here on the further out inside of these radial plots is the technical term we give them, is higher than average, and towards the very center is lower than average. And then the line you can see which says 0 is something that is about average for a city. So we tried to actually try to categorize and try to explain what these types of cities are, and what's so different about them. For example, we call kind of places like Paris and London the 15-minute city, where there's a lot of population, a lot of business activity that you'd be able to harness, but there's not a lot of local generation that's available because it's far away from hydro, far away from wind plants, etc. But there's a lot of innovation that's available. There's places like Singapore and Bangalore that we call consumer cities, where the policies of national governments really kind of lean on consumers to drive change, and it's more of a free market that you have in the future. Places like Buenos Aires we call the all-around city, or the potential city, and these are places where there's a lot of potential for generation, because they're located in places where you have a lot of solar irradiance. There's a lot of land availability that's there, and they have a short but kind of interesting history of wholesale markets that try to incentivize people to use less energy at the most expensive times. There are places like Stockholm and Vancouver that we call the distributed city, that have a lot of available local generation and a very educated population and motivated to use it. That's there, but at the same time, we found that there's the awareness of green issues is almost complacent in a way, that they need to kind of find themselves again. And in places like Nantes or Valencia, we call the available city, and this is where you have large wind farms or solar that's available in the region, but not necessarily right in the middle of the city. But you don't, at the same time, you don't have as much of a dynamic startup environment that creates solutions that are kind of applicable to that local situation. So you kind of have to collaborate between all these different smaller and medium-sized cities to get solutions together. And one of the things that we found is that if you have a really unconstrained energy transition, the amount of electricity you use per hour in a peak hour will easily triple, from moving all of your electricity demand for transport, heating, cooling into the electricity grid, instead of using petrol, gas, district heating to do before that you've done before. And this is something which is, of course, very costly and very unsustainable. And even in places where we don't associate a lot of movement of heating from gas into electricity, there's still so much movement from petrol into electric cars that the same sort of story happens in the global south, even though you already don't have the same issues with heating that you have in the global north. Some of the things that we've been thinking about on urban flexibility and consumer flexibility is that our research that we've done before found that if you actually have real-time pricing that really disincentivizes you, kind of triples, quadruples the price at a peak hour at 6 o'clock, 7 o'clock in the evening, people have electric vehicles or have photovoltaic panels that are on their building use up to 60% less. That is a typical amount that we found with the people's response to that. But also we were thinking, well, these are happening in places where there's there needs to be somewhere for the electricity to go. And if you have an electric vehicle, or you have you have a solar panel inside of the UK where we have this data, you're probably in a suburban environment. You're probably far away from industry or other sectors where they have a need for that electricity that you're storing in your batteries at a different time of day. And we were thinking, well, yes, that's a place where there's nowhere for electricity to go, and they have this change in their demand anyway. Well, what if there is somewhere for the electricity to go in a place like Paris, where you are close to an office, or you are close to another business that can receive this electricity? So there's division between the two that we're thinking about between the availability somewhere of electricity to go and the price incentives that happen within the market. And we were thinking about in different cities that that the urban structure of a place starts to make that much more easy. And so we've developed we actually used the measure of market concentration to be able to understand what is the most mixed city that you have. In this case, 0 would be a perfectly mixed city, and 10,000 would be everything is residential. So you can see that there's places like Singapore and Paris where there's a lot of mixing of residential and commercial areas, commercial within the city, and places like Stockholm and Nantes where they're much more residential than commercial, for instance. And we started to estimate, well, how much of that shift can we have in smart charging and smart heating in cities that are mixed, that there's somewhere for the electricity to go. There's givers and receivers, if you will, that are there at the same time. We'll show some graphic representation of that, and places where there isn't so much. And of course, we also try to understand what is the nature of the market, the wholesale and retail markets of. There's a concept called locational marginal pricing in the wholesale market, where the price changes every half hour based on how much generation and how much demand there is inside of that local area. So if there's a big differential, the price goes up. If it's about the same, the price comes to 0. If they're in the opposite direction, if there's so much generation and not much demand, it becomes negative. It becomes the wholesale market starts to pay suppliers to get people to use electricity. So there's some extreme examples that are around at the moment of the idea of a negative wholesale cost of electricity that's out there. And then how does the retail market start to reflect that? Whether it's flat rates, whether it's something which it just peaks at critical times, or ones which kind of just change every half an hour all the time. And so we can see how much effort is made by different countries. One interesting example is Singapore, where they created an almost perfect wholesale market, and the retailers just ignore the fact that that the wholesale market changes so much and sells it all as a flat rate. Probably is at great expense to the people who are users. And so we started to estimate what this pricing score was that we built from the wholesale and retail market, and moderated a bit with, well, how much innovation is possible within this market based on the digital skills of the population, how much green awareness is in there, and then kind of created another shift with using smart heating and smart charging away from peak hours, which are kind of very carbon intensive and lots of demands in the system, into non-peak hours in the future. So at the end of this, in the example of Paris, we start to bring those lines closer and closer together, but you almost want them to be the same, of a typical peak hour that you see at the top and a typical off-peak hour that you see at the bottom. Using these assumptions that we made about the shift of electricity with smart heating and smart charging, yes, it started to get closer, but it's not that close, right? It's not that close still. And we'll go through kind of and then what is the role of a city block and automation and all this? Well, we tried to imagine what could happen within a city block that has 200 apartments in it and 20 businesses in it, and we kind of made some assumptions about how many people within those businesses and how many vehicles that are generated and parts in the streets that are associated with them. And we still had this is our initial demand that we had that we came up with for all these different apartments and businesses that we had. Non-domestic demand from the commercial buildings, of course, it goes kind of up at the top, and is a bit higher than the residential units during the daytime, but it's much lower in the evening. And what's something that you'll see, which is very typical of residences, is that it goes up massively, very quickly in the evening, and of course. At this point, when you're saying, does the sun shine and the wind blow at 8 p.m. at night? Not so much. So what do you do? What do you do with it? And many policies and cities have focused really heavily on the residential sector for this reason. So if you gave 30% of these apartments batteries and gave them all access to solar panels, you would kind of bring down the peak in the middle. You would actually kind of resolve a lot of the issues in the middle of the day that you see with the orange line, but you still would have this massive peak that you just really could not solve. And that's why we really illustrate why it's so important to have mixed areas of cities. When we say there needs to be some place for the electricity to go, well, this is what we mean when we say that. When, for example, if you're actually charging batteries that could be used later in that peak hour, then it needs to be happening from commercial buildings and residential buildings to be able to have enough electricity available to deal with that peak that you have at 8 p.m., 9 p.m. at night. So it's almost the easy part is the middle of the day. The hard part is the evening, and you actually need both types of uses participating in generating electricity, storing electricity, releasing it late at peak hours. That stored, which is so important, and of course the cheapest form of storage, but very distributed and very difficult to organize, is electric cars. People are going to be buying cars anyway. As an urban planner, I'd rather they didn't, but but it's something which is a free battery resource that uses what we call in the electricity industry vehicle to grid technology. But of course, the problem is vehicle to grid technology is only useful if it's automated and has full participation and cooperation from the users. And these cars are parts at people's homes, at people's businesses, and they could be using all kinds of different retailers' rates, and that's associated with their house, with their office, with their building, with buildings that they visit. So there's a lot of different kind of market issues to sort out. But let's talk about the technical ones for automation. So where are we now? We think about kind of who's the connection of the data that we have is thinking about who's the supplier, who's the consumer. It's assigned to, you have a meter, you have a tariff that somebody uses, they have a property they're assigned to, and then we think about their tariff that they pay, the agreement that they have, it's associated with the property, and finally, you have the data that's gathered from the meter and organized through industry. So this is the model of the data that's being kind of pushed around from place to place. But your car's not parked at your home all the time. It's parked at the business. It's parked in other places. So it's almost, imagine this layered 3 times over is the amount of data that needs to be organized with solutions of vehicles that are charging and discharging. And you're thinking, okay, let's just get everyone to start to kind of charge their batteries. When the evening peak is done, let's charge them all up again. Now, if you actually do it using a model where everyone just plugs in their battery and then they suddenly just start up at midnight, you get a new peak that happens, and you have the problems of a peak electricity demand all over again. So instead of having one that you have at from 5 to 7, if somebody naturally just plugged their car in and just charged it, now it's suddenly midnight to 2. So actually you actually need to almost stagger all these charging events, as we call them, within the electricity industry through the night without making everyone wake up and plug in and pull out their cords of for their cars again. And you need to be able to combine that with some sort of real-time pricing or peak pricing that you do. So if you actually had something at the bottom, which we call critical peak pricing, if you had it just combined with that, then you might start to get these behaviors where just at the cliff edge of the price going up and down, then from a cheap price to an expensive price, you start to get these kinds of behaviors. But with real-time pricing, it varies every half an hour, and a person isn't expected to just know what's happening all the time with the price of electricity. And so one product that we're studying right now within Octopus Energy is called Intelligent Octopus, and we promise everyone you'll have cheap charging.
Just to let you know that you still have like 2 or 3 minutes, if it's okay for you, to keep time for the questions.
Yeah, I'm exactly about 2 minutes away. And we say that you'll have this cheap rates, but you don't get to choose when you have it. We choose when you have it. It'll be between 11:30 and 5:30, but we'll automate staggering it as we go through. So we ask people to, for instance, say how much charge do you want when you wake up in the morning, and we tell them, and you can look on your app, but I suppose you might not look at it that often afterwards, that at 5 p.m. in the afternoon, you see this on the right hand side, that here's the charging schedule, kind of these blocks that you have instead. So in this case, this is 3 hours spread over 3 blocks. And we know from people that when you're actually looking at automation, the defaults are so important. Most people never change what you give to them. So if you're saying that that's the default on the left-hand side, I'm going to be charged 70% by 9 p.m. Almost everyone's just going to, most people are never, hardly anyone's going to change it more than just once to fit their schedule. And it's, of course, like people plug in in the evening and pull out in the morning. We all know that this is what their cluster is, almost a heat map of when they plug in and when they plug out again. And of course, that what you can see as well is this kind of like strip that you see from the bottom left to the top right. This is when people just plug in quickly, charge it manually, and pull it out again. So there's all this kind of behavior you need to account for if you're thinking you're going to automate this process perfectly to manage the electricity grid. And so of course you need to understand normal behaviors of how when people kind of plug in vehicles and give you that control and then pull it out again. And this is the results that you get, this kind of staggered load that you get. And this is the example just from one user. This is the change in stagger that they get all through the last 3 months, 5 months that you see on here. So that's going from kind of the largest scale all the way down to the smallest scale, to think of how cities really are this place for a fast and just energy transition. So thanks very much for the invitation.
Thanks a lot, Stephen, really, for this super fascinating presentation. Like as you show, it's not an easy problem to solve, even with AI, but it's definitely a fascinating one. So if any of you have some questions that you would like to ask, feel free to virtually raise your hand. I have one, actually, if I can ask. I have one because, Stephen, you say that you are working with, at least that you presented this research to the city of Paris, and I was wondering if you are going to have common projects with the city of Paris or some stakeholders from the city.
We don't have an active project that we're doing with them right now, no. But of course, we're seeking the opportunity to do more of a deep dive on the ground to really explore what it really means to have an urban block, what it really means to have electric vehicles as a resource that go from one part of a city to another.
Yes, Gabor?
Hey, I'm Gabor. I work at Google Nest. I work on the smart thermostats. So I'm kind of familiar with the whole technical problems behind shifting customers' energy behavior. I'm more interested in the business side and where you think the change will come from. Do you think that in the end it's going to be the electric suppliers need to change, or will there be some kind of middleman who will manage the electricity? Like, if I understand correctly, Octopus Energy is a supplier, right?
We are a supplier. We also manage investments of renewable energy and have and manage electric vehicle fleets and heat pump and smart meter installation as well.
So it's a very wide, diverse business portfolio.
Yeah,
interesting.
Many bets that are happening at the same time. One of the reasons why we established the Clean Energy Cities project is that we think that local authorities really need to start taking a more active part of being a middleman. And there's some examples that you can see that have been done already, such as collective purchasing of heat pumps or solar panels being organized by cities, so people can get prices at scale, which they couldn't get as an individual. There are a lot of calls for electricity suppliers to be more of a middleman of the payback of your, for example, kind of the heat pumps that you put in to renovate or retrofit a building are something that you pay back on your electricity bill, for example. But there needs to be a question of kind of the innovations that are being made. I think you mentioned Google Nest as an example, and smart thermostats as an example of if you're actually if there's more something more than saving electricity, that you're being really paid to not use it at peak times, for instance, more even more. So that's some suggestions from that we haven't made, but it's being made within a report that we've worked on with Peter Crampton, who I think those who know the electricity industry knows that he's been an advisor to interconnectors and grids around the world for a long time.
So just to follow up, so you think that the utility companies need to sort of evolve their business model? Like the current one is not feasible?
I think they'll always have to evolve. I think the way that they operated 20 years ago wasn't feasible in today's climates. But also, so yes, I mean, I think it's kind of stating a bit of the obvious that what works today is not going to work very well in 10 years' time.
Makes sense. Thank you.
Gustavo?
Hi, Steven. Thank you very much for your presentation. It was very enlightening. Well, I am from Ecuador. I currently work as a data scientist on a startup that works in Latin America. And I have a question more related to infrastructure. From what I read about the topic, one of the major bottlenecks or pains in this kind of zero carbon industry is the applications of batteries. So because at the moment they are currently very expensive and they are not affordable for like the whole population in general. How do you think in your model that this should be applied? Do you think that in 10 years, probably batteries from Tesla or other companies are going to be so cheap that it's going to be available for the whole market, or that the city municipalities have to do this investment in order to create the zero carbon environment?
Well, there's a couple of things I say. I mean, one is the obvious one, which is a lot of it depends on China, because they're by far the biggest investor in battery technology. Like they're, I mean, there's an argument that's out there saying Western governments are so far behind on battery technology and hadn't done the investments, and we're almost lost the next 10 years and need to actually make the investments that will kick in about 10 years time to actually have more effective battery technologies that are being built. In the meantime, one things that we've said is that maybe home batteries are not going to be that affordable for people. They might do it associated with installing their own solar panels on top of buildings, might make it affordable, but people are going to be buying electric vehicles and not thinking about the cost of the battery as something that that is too expensive. It's almost like an economically illogical amount of money to spend, and so those things will be available for people to trade using vehicle to grid technologies. And I think that we need to really seize on that as part of the infrastructure that we have in the future. And also we need to encourage businesses to be better investors in battery technology in the future. So I would say for the domestic sector, really depend on electric vehicles, and we need to work more effectively with the commercial sector to see that as something which is that really makes them money in the long term, in their long-term investment strategies.
Tanya?
Oh, hi. Thanks, Stephen, for the lecture. I have a question about scale. So part of in the presentation, you said in the future we'll have more local generation and storage of energy, and so it makes more sense for infrastructure or governance to be done at the city scale rather than at a national scale. I'm wondering what makes the city the correct scale or the ideal scale, and why not, even smaller scales like a neighborhood or a building, or larger scales like a region? What makes cities a good scale?
No, it's a really good question, because the answer is it kind of depends on the type of city we're talking about. So if we're talking about really fine-grained cities, such as when we talked about the 15-minute city being a place like London or Paris, or even kind of other kind of medium-sized cities, which are quite mixed, but within the urban block, or vertically mixed, as we call it in the architecture world, the argument of a neighborhood or a building scale might actually start to hold water. And as you get kind of in situations where a lot of generation or wind farms are available in the region but not inside the city, you're talking probably more of a regional or even back up to national scale of organizing the import of electricity into that city. And then you have others such as when we said the all-around city or distributed city that we have, where it might be more just at the the city region scale. That is the best scale to actually think about policy for sustainable energy in the future. So it's a good question, and something that we've been thinking about and it's almost associated with kind of what is the size and the location of distributed energy resources or variable renewable energy that we might put in. That is everything from heat pumps and solar panels and or even wind energy or storage. Is it the size of a building? Is it the size of a neighborhood resource? Is it the size of a citywide resource? And it depends on the type of city what works for them.
Can you explain a bit why in like the 15-minute city, it makes more sense to have smaller scale, like neighborhood building scale?
Because that's the scale of delivery. So you'll be importing a lot of electricity from the national side, from kind of the national grid. Of course you will, but to actually get that balance of energy, which lowers the carbon intensity of electricity use in the city, you're probably talking about kind of delivery on roofs of buildings, delivery of delivering a solar on roofs of buildings, delivery of batteries at building scale, and so it'll be something which is much more distributed than in size than other places.
So it's like lack of space for these larger scale. Is that what you mean?
That is that's the reason that having these smaller kind of units is a consequence of that lack of space available.
Okay, clear. Really interesting. Thanks.
Hello, very interesting lecture. I'm working as a sustainability and physics engineer, and so I'm based in UK. And I was wondering, like going back a bit in the battery conversation we had, like just a thought on something that is happening at the moment in Greece. So in Greece, they're investing into wind power. So they started projects on like putting wind turbines in different kind of mountains. And what you get out of that is that you haven't educated your citizens in what this can bring. At the same time, you don't have like the capacity to store this energy. So you're creating kind of you have like make your population against the investment in renewables, and then you also don't use this kind of energy that you're producing. So I was wondering, like, if you are like your opinion on like how would you consult kind of a national national kind of pathway, because one thing is the pathway, how can you achieve your net zero net carbon kind of grid, but then at the same time is like what do you do in the meantime, like investing in bigger scale renewable power, or like maybe like a more tailored cities, like in the buildings to have individuals, let's say solar panels on, and using this energy. What would be kind of the right way to work with that?
Well, I would say that one of the great statistics that's out there is that 7% of all the renewable electricity that was generated last year worldwide wasn't used for anything. It just disappeared. It wasn't stored. And it didn't really provide any capacity into the market. And this is the political question that needs to be made at the national level. Are you willing to accept less efficient, less efficient renewable energy units, such as wind turbines or solar panels that generate less electricity, but they're closer to where people demand the electricity, than really flashy, large-scale developments that look fantastic to you as a prime minister when you go to the mountain and open it?
Yeah, this is my critical question on that thing. Well, yeah, I feel we don't have answers on that, or like, yeah.
Okay, sounds great. I think we already like at the end of the session. Like we no longer have any questions. Thanks a lot, really, Stefan, for taking the time to answer all the questions, for the super insightful presentation. I think that the fact that you also focused on Paris is super interesting for the final project. So yes, this is the end of the session. This is also the end of actually all the lectures of the program already. If you want to stay in the breakout room, as I said it on Slack, I can present you the groups for the final teams, and like this we can also discuss it. And if you cannot, it will be posted in 1 hour on Slack. So yeah, thanks again, Stefan. Thanks everyone, and yeah, bye.
Good luck with the project. Hope to see you later.
Thank you. Bye.
Okay, I will stop the recording right now.